so we are on 3.1 in your note packet, so make sure to have that out. Parallel lines are two lines that are equidistant. So if we break that word apart, equal and distance, right? And do not intersect. Perpendicular lines are two lines that are intersecting. And they intersect to form a 90-degree angle. Intersecting, crossing at a 90-degree angle. Something we should remember is that on parallel lines, slopes are equal, but on perpendicular lines, they are opposite and reciprocal. So what I mean by that, like if I had one line that had a slope of 1/2, opposite of 1/2 would be negative 1/2. But then the reciprocal would be to flip it, right? So it'd be negative 2/1 or just negative 2. So if I had a slope of a positive 3, opposite reciprocal to that would be negative 1/3. Okay? Okay, skewed lines are two lines that are not intersecting. They will never intersect. And do not lie on the same plane. So skew lines will never, ever, ever intersect. So if I think of skew lines on these two planes, so this plane right here and this plane over here, maybe it's a line going horizontally this way, and the line over here that's going up and down. So those will never cross because they're on two different planes, and they will just never cross. Okay. Think of each segment in the diagram as part of a line. Complete the statement with parallel, skew, or perpendicular. So WZ, this line right here, and ZR are perpendicular. Okay, so pause me and do B through E on your own. Next one is W to Z and S to T. Those guys would be parallel. Q to T and Y to S. So those will never cross. So they can't be perpendicular. They're not parallel. So therefore, they are on two different planes, so they are skew. Plane WZR is this front plane, okay? And SYZ is the side plane. So those two planes intersect at a 90-degree angle, so they are considered perpendicular. Plane RQT, so RQ2 is the bottom, so what it's sitting on. And YXW is the top. So the top and the bottom would be parallel to one another. All right. Postulate 13. If there's a line and a point on that line and a point not on that line, then there exists exactly one line through that point that is parallel to that line. But then postulate 14, perpendicular postulate. Think of postulates. You may have proofs with these postulates, right? If there is a line and a point not on the line, then there exists exactly one line through that point that is perpendicular. Okay, let me draw a picture to help you. So if there's a line, so we have a line, and a point not on that line, there's only going to be one line that goes through this point that will be parallel to that. Oh, and guys, the symbol for parallel looks like another arrow in the line. Same thing here. We have a line, we have a point not on the line. There's only going to be one line that goes through that point that makes these two lines perpendicular, is what this guy is saying. Sketch the described lines on the given image. We have line G through N that's parallel to MP. So here's my point. It has to be parallel to MP. And I'm going to draw my symbol on there to show that those two things are parallel. Line H, oops, I need to label this G. Line H through P is perpendicular to MP. So it would go straight up and down. It would also then become perpendicular to this line G because these two are parallel, right? And I would draw my perpendicular symbol to show that it is perpendicular. I name it H. All right, next page. So a transversal what a transversal does is it cuts through two other lines, okay? So it is a line that intersects two or more coplanar lines at intersecting points, or at 2 points. So it intersects this line and this line at those points. So P, in this situation, would be my transversal. So P is my transversal, and it intersects M, and it intersects N. Okay? Corresponding angles. So an angle formed by an angle pair formed by two lines in a transversal that lie in similar positions of each intersection. So what I like to do, or how I like to think of this, is here are my two lines, here's my transversal. I like to think of this as a box, and this is another box. So 1 lies in the upper left-hand corner of the box. 5 lies in the upper left-hand corner of the box. So 1 and 5. 2 corresponds with, so upper right-hand would be 6. 3 is lower left-hand, so that would be with 7 lower left-hand. 4 and 8 correspond. So those are corresponding angles. Alternate interior angles is an angle pair formed by two lines in a transversal that lie in between the two lines and on opposite sides of the transversal. Okay, so alternate interior. So we're talking about interior, inside. So these are my interior angles because they are in between or inside the two lines. These are my exterior angles because they lie on the outside of the two lines. Okay? So if we're talking about alternate means opposite kind of, right? Alternate interior angles. So we're on the inside because it's interior, so in the yellow. Alternate would be opposite sides. So 3 would be alternate to 6. So it would be angle 3 with angle 6. And then also alternate would be 4 with 5. So angle 4 and angle 5. Alternate exterior, so opposite alternate exterior in the green. So angle 1 and angle 8. Or angle 2 and angle 7. Maybe I need to fill in the blanks also though. So alternate exterior is an angle pair formed by two lines in a transversal that lie on the outside of the two lines and on opposite sides of the transversal. Consecutive angles. Consecutive angles is an angle pair formed by two lines in a transversal that lie in between the two lines. So in the yellow, inside, and on the same side. So in between in the yellow, so that would be these right here. And we're talking about consecutive, so they're in a row. So it'd be angle 4 with angle 6, and then angle 3 with angle 5. And that is all for this lesson. Okay, so you guys have 3.1 homework to complete after this lesson. Thanks, guys.